Hello everyone, we're back for our ninth chemistry squad. Super exciting. It's actually our penultimate one, which is a bit of a shame, but I guess all good things come to an end. But I'm sure my tutor will do another round of these chemistry squads. But we've actually started on time for once, which is always a nice surprise. Hope you're all well. I can see a few of you are sort of joining really slowly. Today we're going to be going over earth signs. I know that the thumbnail is a little bit crude. I had to do a little bit of editing really quickly. But yes, we're going to go over earth signs today because I know there was a lot of, what's the word I'm looking for here? A lot of demand to go over the earth of atmospheric chemistry. So that's what we're going to look at today. Riam, hello, good to see you again. Still see that you're rocking the good old Psyche K profile picture. Goated anime, brilliant. Good to see you again. I hope you're well. Hope GCC is going well also. Hope your day's been okay also. Hope you're excited for another chemistry squad. It's going to be super exciting. I think we're just going to give it 2 minutes or so, so 2-3 minutes or so, just for everyone to sort of get comfortable, get a cup of tea, and then when we're all ready, we'll just get started, really. We'll get started at 5 past. Ironically enough, I think I said that last week, and then I had an urgent call to attend to. So hopefully that doesn't happen, touch wood. Ella, hello, good to see you again this evening. Thanks for rejoining. It's great to see you all again. Great to see you. Hope you've been okay. Hope GCSEs are going well. I'm sure you guys are smashing them. You guys have done really well across the last 9 squad sessions. I guess this is number 9, isn't it? And I'm sure you guys are going to do really well in this session as well. Good to see you again. How's everyone feeling? It's March now, so I guess you guys are getting really close to your exams. A little bit of advice I'd give you all, just make sure to keep up with regular revision. Don't try and cram things in at the last minute. Cramming just doesn't work. Give yourselves the time to really understand the content that you're trying to revise. But I'm sure you guys will be absolutely fine. You know, I've seen how brilliant you guys are in the squad session so far. So, you know, that's what I would say there. Okay. Misam, hi, good to see you again. Thanks for rejoining. Hope you're well today. And Inga, our lovely moderator, good to see you again. Thank you for moderating again. As I always say at the beginning of the squads, we do have 2 other brilliant squads tutors, so do check them out. They can be found on the YouTube channel of the My Tutor YouTube channel. Also, click on the link that Inga has put in the live chat. If you want to see future squad sessions, then you can click on that link and you can get reminded of them. You can share that with your friends. They can also be reminded. So do make sure to click that link also. Also, before I get right into it, towards the end of the session, Inga will share a link, a feedback link. Super important you guys fill that out before you leave the squad session tonight, because since this is the penultimate one, so this one the next week and that's it for this term, the more feedback we get, the better it is for you guys, because then it means that we can go back and we can redesign the squads to a format that works for you, because we want you guys to be the best students that you can possibly be, and so we need that feedback in order to really make something that works for you. So do make sure to fill in as much feedback as possible. Misam, you've asked which C is it? Is it C5? And Riam, you said it's possibly C6. So I am going to cheekily have a quick look. That's AQA's formatting in terms of the specification. I'm going to have a quick look to have a look for you. Let's see, AQA. It's atmospheric chemistry. I think it's C6. Off the top of my head, I think it's C6. Atmospheric chemistry. Let's have a look. Let's have a look here. It's topic 9, if that helps. It is topic 9. I think that might be C6. So have a look. It is on the AQA specification though. So have a look. Well, it comes on a 4.9 on the specification, so that might be C5. Chemistry of the atmosphere is C9. Okay, fine. So that's answered that question then. That's answered that question. Fantastic. Right. Well, it's 5:06, so I say we just get right into it then, shall we? Now, I'm going to attempt to use my graphics tablet today. As I've said before, I am not an artist. If anything, I'm fairly certain that my art teacher told me specifically not to do art at GCSE. So I think there's a little bit of lag action. I think it might be because I'm using the graphics tablet. So I'm going to take the graphics tablet out, and I'm just going to use my trackpad instead. Hi, Mikhail. Good to see you. Okay, so let's get right into it then. And I guess without my graphics pen, my drawing's going to be even worse. So, when we think of the atmosphere, and I'm going to write today's atmosphere, what are some of the gases that you guys can think of? Like, what gases are present in today's atmosphere? Let's get a conversation going in the chat. What can you guys think of? And I'm going to do this in green, because I always think of green whenever I think of the atmosphere. There we go. So what gases can we think of? Okay, so me, Sam, I've got nitrogen and oxygen, carbon dioxide. Charlie, you've given nitrogen and oxygen as well. Good to see you, mate. Thanks for rejoining. Fantastic. You guys are smashing it. Methane, CO2. All of these are really, really good suggestions, guys. Well done. So we're going to type all of that out. So we're going to say carbon dioxide, oxygen, nitrogen, methane. What else did we say? I think we said some other things, didn't we? I think that's it. I'm going to add a few others, like argon, for instance. Okay. Now, out of curiosity, which gas do you think is the most abundant in that list? What do you guys think? What is the most abundant gas in that list? You'll be surprised, actually. Some of you may already know, but let's have a look. What is the most abundant gas in that list? Oh, you guys have absolutely smashed it, but then I expected nothing less from the best chemistry squad that's out there at the moment. You're right, it's nitrogen. So nitrogen is actually the most prominent gas in our atmosphere, followed closely by oxygen. Then after that, you have carbon dioxide, and then argon, methane in smaller quantities. So yeah, Charlie, you're right. Nitrogen is anywhere between maybe 78 to 80%. Oxygen is about 19, 18%. And then the other gases are kind of whatever's remaining. I think carbon dioxide might be 0.06%. So you have really, really small proportions that we wouldn't really think about too much. But yeah, no, well done. That's fantastic. So that's today's atmosphere. Now, in this session, we're going to go over a few things. We're going to go over what the previous atmosphere looks like, but we're also going to go over how we went from the previous prehistoric atmosphere to today's atmosphere, and then we're going to talk a little bit about the greenhouse effect and how this balance of gases may be being thrown off a little bit, mostly by human activity. So let's have a think then. So let's go right back to the Earth's early atmosphere. Now, just as a quick show of hands, who here has watched Star Wars? I don't expect you to watch all of them, but even if it's just episode 3, that's the one I'm going to reference to here. And it is relevant. I promise you that my comparison is relevant here. Okay, so Mikhail, you said no. Again, that's fine. I think I might be showing my age here. I don't think many people have watched the prequels. No, again. Okay, so Charlie, you watched it. Fine, okay. So I'm going to reference episode 3. There's a scene where Anakin Skywalker and Obi-Wan are fighting on this lava planet, right, called Mustafar. And essentially, I'm making that comparison because that's what the Earth's early atmosphere looks like, okay? Back in the Earth's early atmosphere, and I'm going to type this out, I'm going to do this in red. The Earth's early atmosphere had lots of volcanic activity, okay? Now, all that volcanic activity meant that we had a high concentration of certain types of gases, okay? Generally, we would have had loads of carbon dioxide, and we would have had lots and lots of methane as well. okay? And we wouldn't have had very much oxygen. So let's type that out. Lots of carbon dioxide and methane, very little oxygen. Now, what do you think that then means in terms of life? Do you think that type of environment is able to sustain life in the Earth's early atmosphere? What do we think? I think it's a really, really clear answer, but again, just want to get a conversation going in the chat. Do we think that kind of atmosphere would be able to sustain life? Yeah, guys, smashed it, well done. So no, so the Earth's early atmosphere would never have been able to sustain life. There's no oxygen whatsoever. There's not much water. It's very volcanic, very, very harsh conditions. Okay, and actually, take Star Wars aside, this is the type of environment that is very akin to Mars or Venus. Okay, and as we know, well, I guess Mars, they're looking into making it more habitable for life, but we're not quite there yet. Okay. Additionally, it's not just these things that would have been produced. We would have also produced lots of nitrogen as well from all these volcanoes. And we could have also had a little bit of ammonia as well. So we would have produced some ammonia too, and nitrogen. Okay, so lots of stuff going on here. But fundamentally, it's not suitable for life. Now, we moved on from that point. And when the Earth then started to cool down, what we then found, okay, was any water vapor that would have been produced would have cooled down to form the oceans. Okay, so as the Earth cools down, water vapor that may have been produced by some of this volcanic activity, this condenses and forms oceans. Now, I'm going to do this in blue. Now, when all this water vapor cools down to form all these oceans, the consequence of that is that then all this carbon dioxide that we had in the atmosphere could dissolve. Okay, carbon dioxide dissolving in these oceans, okay, produces carbonated rock. So Rem, you've asked, how do scientists find out about this stuff? That's a very good question. I suppose there are different ways in which you could look at the history of the atmosphere. You could look at different isotopes. You could look at rock compositions, and then you could, based on what you have in those compositions, you could extrapolate back and say, okay, well, I would have had these isotopes then, but I don't have these isotopes now. I'll be honest, I'm not a geologist, so I wouldn't be able to say in too much detail, but that's a hypothesis. These are all theories. I think the vast majority of them are theories. I think some of it is proven to some extent, but I think most of them are theories, yeah. I think most things in science are theoretic. So you could take evidence, and then based on that evidence, you can then propose this happened, and then what your theory is, and then based on data, is what's based on data. So Charlie, you've given a really good example. You could look at ice cores, and they can analyze bubbles of air in them. So those bubbles of air in those ice cores would have a different composition compared to the bubbles of air that you have now. Okay, so that's one point you could make there. Hope that makes sense. Hope that kind of answers your question. Okay. But again, this is just a theory of the early atmosphere, but you can give evidence to this theory based on data, on empirical evidence. Okay. Now, if we then look at the Earth cooling down, okay, the point of the Earth cooling down is that then all this carbon dioxide that was in the atmosphere can dissolve and form carbonated rock, okay? And the evidence that we have for that is that we actually have carbon dioxide, locked away in rock and in the ocean. Now, the other thing as well that we can say is that now that we have all this ocean matter, this is going to reduce the concentration of carbon dioxide in the atmosphere, okay? And at the same time, because the Earth's cooling down, we have water, it's less harsh, we then start to introduce life forms, okay? Now, algae and plants in particular, so life forms that aren't particularly high maintenance, things that can survive in very limited conditions, okay? They can use some of that carbon dioxide that's in the atmosphere, and they can then produce oxygen. What is the name of the process by which things like algae and these very, very simple plants would have been able to take that carbon dioxide and produce oxygen? I know you guys know the answer to this one. What do we think? I'm going to type out the answer as soon as you guys have said it. Okay, I see one answer. Nisam, you said photosynthesis. Do we all agree? Riam, you've also said photosynthesis. Charlie, you said photosynthesis. Yes. Well, Michael, what I'd say here is trees and flowers. Probably not at this stage. We would have trees and flowers later on, but very, very early on, we'd probably have, really small, simple plant-like organisms like algae. But yes, you're all on the same page. It's photosynthesis. Okay. So what we could then say is that all these algae and small plants can then utilize photosynthesis. Okay. And by utilizing photosynthesis, they can take in that CO2 and release oxygen. Now, by releasing this oxygen, what that then means is that the concentration of oxygen in the atmosphere is going to go up. And we're then going to see an increase in the stability of the atmosphere. So then we can accommodate for more complex life forms. And over time, that would include organisms such as ourselves. Okay. Now, we know that algae appeared about 2.7 billion years ago. So this is a while now. Okay. And the evidence for that is that oxygen then became more predominant in the atmosphere just shortly after the introduction of algae to Earth's sort of ecosystem. Okay. And as we know, that would then cause a decrease in the concentration of carbon dioxide. And this is what leads us to today's current atmosphere. Does that make sense? Does that make sense for everyone? Does anyone have any questions on anything that I've said? Or, yeah, if anyone has any questions, then do say. No such thing as a silly question at all. I'm just going to change this to purple, just so it's a slightly different colour. I know I wouldn't necessarily associate purple with plants, but, it keeps things interesting. There we go. Riam understood. Fantastic. Are we all in agreement then? Yeah, we'll give it one more minute, and then we'll just keep the momentum going. Because then what we're going to do is we're going to talk a little bit about the greenhouse effect. That makes sense to everyone. Michael, you said same. Fantastic. Glad it makes sense. Great. So, let's then move on to the greenhouse effect. What do we understand by the greenhouse effect? And actually, oh, hang on a second. Misam, you've asked, could you explain how it goes from carbonated rock to algae in plants? So, it's not necessarily the case that we go from carbonated rock to algae in plants. What we're just saying is that as the Earth cools down and that water vapor forms oceans, any carbon dioxide that was in the atmosphere can dissolve in the oceans and become sedimentary rock, where carbon dioxide is locked away. Simultaneously, the introduction of algae and small plants to the Earth means that they can take in that carbon dioxide from the atmosphere, and that then produces oxygen. Hopefully that makes a bit more sense if it didn't before. What I was going to ask was, what do you all understand about the greenhouse effect? Additionally, is the greenhouse effect a good thing or a bad thing? I'm really curious to see what you guys know and what you guys understand, because I think that the greenhouse effect gets a really bad rap. And this isn't me trying to convince you that the greenhouse effect is a bad thing. It's me trying to see what you understand. So Ellie, you said it's a bad thing. Okay. And Riam, you said that it's gases like CO2 and methane trap sun energy and use them more than needed. Okay. Okay. Let's get one more answer. And Mikhail, you said it could be a bad thing and a good thing. Okay. Let's have a think here. Okay. And Charlie, you said the greenhouse effect is where emissions like CO2 and methane keep heat from the sun within the atmosphere. Okay. I think we're all on the same page. Okay. If we think a little bit about the greenhouse effect, okay, the greenhouse effect in of itself is not a bad thing. And this is what I'm going to attempt to draw. Again, keyword here is attempt. Let's take the sun, for instance. Okay, so we've got our sun over here. It's all smiley, fantastic. And we've also got the Earth over here. Okay. Now, what we need to remember is that the sun is emitting all this infrared radiation. Okay, as it's emitting all this infrared radiation, some of it is needed to heat up the Earth. Now, long wave radiation that is able to get through the Earth's atmosphere, okay, some of it is absorbed by the Earth, and then some of it is then re-emitted by the Earth at a smaller, shorter wavelength. Now, what the greenhouse effect is where you have gases like carbon dioxide and methane, they can retain that heat, okay? And under normal circumstances, that's actually quite important. The greenhouse effect is the reason why the Earth generally is about 18 degrees rather than minus 25, okay? So, on one hand, it's a good thing. However, I think what all of you are referring to is the enhanced greenhouse effect, which indeed is a bad thing, which is where we are producing more carbon dioxide and methane and other such greenhouse gases than is necessary. Okay. Now, we've already mentioned things like carbon dioxide and methane. I want you guys to give me examples of processes that release carbon dioxide and methane. List some human activities that release carbon dioxide and methane. It could be industrial, it could be agricultural. Give me some examples. Deforestation. So that's a really good one there, Rehan. If you think about deforestation, we're cutting down trees. Now, cutting down those trees involves machinery, which is going to release lots of carbon dioxide. But we're also cutting down trees which take in carbon dioxide via photosynthesis. So then we're losing carbon sinks. Very good. I see a lot of combustion there. That's a classic example. Yeah, so obviously if you're burning things, not only do you need fuel to burn something, but then that's going to release carbon dioxide as well. Respiration, yeah, so that's true. Respiration does release carbon dioxide. I suppose if you have more humans, then yes, we are respiring more and more organisms. I wouldn't necessarily say that respiration is as much of a driving factor though, but it does release carbon dioxide all the same. And yeah, burning of fossil fuels. Cows releasing methane, also a really good example. So if you think about how there's been an increase in the demand for things like beef and other red meats, all those animals, they will produce methane. Rice also produces a lot of methane because we make it anaerobically. So if you think about it, all these different things are causing an increase in the concentration of greenhouse gases there are in the atmosphere. And therefore, we're keeping more heat in. Imagine that the Earth is wearing a jumper, okay? And I'm going to do this jumper in green. Normally, the jumper is only this thick, so it only retains X amount of heat, okay? However, the problem lies in the fact that because we're producing more greenhouse gases, we're putting like a thicker jumper around the Earth. So it's retaining a lot more heat, and as a consequence, the global temperature is slowly increasing. And that's causing changes in certain ecosystems. It's causing changes in certain climates. So we're seeing melting of the ice caps, for instance, which is causing a loss of habitats. And so that is why there's a massive push to try and use greener fuels and try and move away from fossil fuels and the combustion of fossil fuels. Okay. Now, what's really important to remember with GCSE chemistry as well is that you can't say that any of it is causative. I see a lot of chemistry questions in exams where they give you lots of information, lots of data, and they might ask you to sort of look at the data and then talk about that in relation to the greenhouse effect, or the enhanced greenhouse effect, I should say. At this point in time, you cannot say that this causes this. All you can do is say that there are relationships or correlations between the two factors, and that's the important thing. Mikhail, yes, transport and vehicles would be another thing as well. So if you think about the combustion of vehicles, or like things like petrol and diesel, they're also going to release carbon dioxide and other quite nasty gases to the atmosphere. I guess arguably that's why there's a push for more electric vehicles or hybrids. But at this point in time, electric, and this is more my opinion, I don't think hybrids are that affordable to the everyday consumer. And we're quite behind in terms of putting all these charging points in there as well. So I think a lot of people are still relying on more conventional fuel vehicles like petrol and diesel. And I know, yeah, you have a congestion charge, but then you just make it more expensive for people to use their vehicles. So, electricity, I suppose, would, contribute to the greenhouse effect because, you need generators, okay? Hybrids need electricity and producing it needs factories. Yeah, no, you're right. So I think what we need to try and realize is that it's not going to be a completely carbon neutral situation. At the point that you're using the vehicle, sure, it won't release greenhouse gases, but that's not to say that in the manufacturing process, greenhouse gases weren't emitted at any point. Hopefully that makes a bit more sense. But otherwise, I think that summarizes everything with regards to atmospheric chemistry. I know there's a little bit more with regards to maybe thinking about how to reduce the production of greenhouse gases, which unfortunately we won't have time to go over today with regards to atmospheric pollutants. But what I would say, though, is if you just go over it independently, we've sort of talked about this already. We've sort of talked about combustants, the combustion of fuels, we've talked about vehicles, we've talked about deforestation. The only other pollutants we didn't get to talk about today were things like I guess not sulfuric acid, but sulfur dioxide, which can cause acid rain, and different particulates. Could we see an exam question on this topic? I'll tell you what I would recommend, since I don't think we'll have time for me to pull up a question before the half an hour is up. If you all, after the lesson, go on Physics and Maths Tutor and you navigate to the exam board that you're under, you will be able to find loads and loads of past paper questions on these topics. Specifically this one, and for other topics also. I don't know whether you guys are aware of the website already, but I think it's a really, really good website to use. And I would definitely recommend using past paper questions as part of your revision. What I can also try and do is after the session, I can pop a couple links in the comment section on this video when the video uploads to say, hey guys, check out these websites for these exam paper questions. Mikhail, the website is called Physics and Maths Tutor, all one word. But thank you for joining today, guys. It's been really, really fun. Do make sure to firstly smash that like button, but also make sure to fill in the feedback form. It's super, super important. It's super, super helpful. And it just means that we then know how to structure these sessions and we know what you guys want out of them. Could you start on showing us questions on the topic we discussed from next week? Okay, that's a good idea actually. So let me actually pull up my schedule. So next week, which is actually our last session for this term, I have jotted down, we're going over polymers next week actually. So I think what I'll do is I'll also pop a link to some polymers questions for you guys to have a go at in the comment section of this video when it drops. Would you guys prefer AQA questions or LXL questions, or should I put a bit of both in? Let me know, because that'll be really useful. And then what I'll do is I will put the questions and the mark scheme to both sets of questions, and then that means you can do the questions and mark them yourselves afterwards. Okay, I see an overwhelming amount of AQA, so I'll put an AQA set of questions in the comment section of this video, so do make sure to check out the video as soon as it drops. Yeah, and you can check out those questions on polymers, and after that, you can come back to the next session having done those questions with a bit of an idea of what we're going to be talking about with regards to polymers. But otherwise, that actually sums it up for this session. I hope you guys found... Oh, can I also do EdXL? I can do EdXL. I will jot that down on my to-do list. That's not a problem. That is not a problem. AQA and EdXL. Fabulous. Okay. So, otherwise, that actually marks it for the session. I hope you guys found it really, really useful. I hope you guys found it entertaining. Um, is entertaining the right word? Is educational would be the more appropriate word. um, but once again, thank you so much for joining, guys. There is no chemistry squad without any of you, and it is so encouraging to see every single one of you joining every week and getting as involved as you do. I'm super proud of you, and I have no doubt that you guys are going to smash your exams in the summer. Very good, but wish it was longer. Well, you know what? That's good feedback. Make sure to put that in the feedback form, and then if we go back to our sessions, we'll go back to our sessions if my teacher allows. But yeah, make sure to put that in the feedback form. It's super important, and make sure to smash that like button also, because that also helps us know what you guys like. Could you give the best tip for chemistry until GCSE exams start? My tip is consistency. Go through your specification. Identify which topics you struggle with yourself, and then prioritize. Do you have a good set of revision notes? Have you been practicing past paper questions? And then from there, you can then figure out how you go about strategizing your revision. Is it content you need support with, or is it exam technique you need help with? And then you'll know what to do. Knowledge is power at the end of the day, especially when it comes to chemistry. So do make sure you look at your specs, see what it is that your exam will tell you that you need to know for each topic, and then assess for yourself whether you know that or not. That would be your first starting point. Hope that's helpful. But otherwise, guys, I'm going to head off now. Once again, thank you for joining. It's always a pleasure to spend time with you guys on a Wednesday afternoon. I'll see you all next week for our last session for this term, 5 p.m. on Wednesday. But take care, stay safe, and keep smashing chemistry. And I'll see you all next time. Bye-bye for now.